Last time we started talking about the joint Gaussian and then we stopped because of the time. So just to recap, joint Gaussian learning values are very important because we will see them when we talk about the random process, Gaussian random process. So basically it's a set of random values or constants that you need to master. الآن الفكرة كالتالي. If you have a single random variable with Gaussian random variable, mean m and sigma square as variance, then this is the PDF. It's some constant that in the variance, and then x minus the mean all square divided by twice the variance. خلاص؟ الآن عندي another random variable y with the same with another means. هذا نسميه mean 1. Okay. وهذا نسميه mean 2. And sigma y squared. Okay? Then the PDF will look like this as well. Wow. 2 pi sigma y squared and e to minus y minus m2, right? Squared divided by 2 sigma y squared. خلاص؟ Now if I have two independent random values, then basically if x and y are independent, ايش معناه يا شباب؟ Means that the PDF of x and y, the joint PDF, to the product, okay, اللي هي fx and fy, صح؟ الآن if I multiply this with this, what do I get? Constant multiplied by constant, صح؟ Multiplied by exponent to e minus x blah blah blah, multiplied by exponent with e minus y minus x. If I multiply two exponents, then I can have one exponent with the addition. So basically, I have, if they are independent, then I have the joint PDF as constant multiplied by one exponent with one exponential with exponents as minus a term with minus x, minus x minus n1 squared divided by 2 sigma, and another term with this. So now, if x and y are independent and every one of them are Gaussian, then both of them are called joint Gaussian. Okay? And when else they are joint Gaussian? If they are not independent, they can be حاجة اسمها joint Gaussian. ايش يعني joint Gaussian؟ هم Gaussian مع بعض. Okay? When the joint PDF looks like this, a constant, مثل الكونستانت اللي هنا. تمام؟ However, the exponent كان الاكسبوننت ايش؟ يعتمد على هذا الترم لو تلاحظوا. If they are independent, then the exponent of fxy will be this and this. صح ولا لا؟ If they are independent, ما معناته بعض. الاكسبوننت حق البي دي اف will be this and this, is it? صح شباب؟ Now if they are jointly Gaussian but they are not independent, بينهم علاقة. يتفاعلوا مع بعض. Then in this case, what happens is there is a term that connects them through the correlation coefficient between them. هذا الترم هو الconnection between x and y. هذا الترم اللي يعطيك how x is related to y through the correlation coefficient. واضح؟ Now, if we plot this PDF, it will look like زي ما قلنا the bell shape. So it's if this is x and this is y, then basically it will look like the bell shape. Then here goes. الآن if the variant طبعا this is the mean of x, هذا هو mean of x bar, and this is the mean of y, which is y bar, where basically this is the center of mass. And the center of mass. تمام؟ Now if the variance of x is large compared to the variance of y زي ما قلنا بيكون هنا بيكون هذا البل عريض في اتجاه x ونحيف في اتجاه y. واضح؟ بينما إذا كان the variance of y is larger than x it will be عريض في اتجاه y وشوية أنحف في اتجاه x. خلاص؟ الآن we call الآن هذا طبعا 3-dimensional function تعتمد على x و y explicitly powerful. أوكي؟ الآن we call الcontour of fixed PDF يعني الآن if this is x and this is y and this is the PDF إذا حجم هذا إذا أقطع من مكان معين ببلين معين يعطيني الكونتور of fixed PDF. If you look at it from upstairs, upside, it will look like this. عارفين ايش هذا يا شباب؟ This is the way the PDF looks like from when I cut it at a certain point. Okay? This is called the locus of constant values of PDF. PDF. طبعا. Basically, if you زي ما قلنا if you look at this PDF, if you look at if you cut it in a plane, then this plane, if you look at it from up, will look like this. Okay? الآن تعتمد على طبعا the location of this locus will depend on the X bar and Y bar. صح ولا لا؟ إذا X bar كبير حتكون هنا، إذا Y bar كبير حتكون هنا، صح؟ الاثنين صغار حيكون هنا، إذا نيجاتيف حيكون هنا، صح؟ So basically the location of the contour of this locus will depend on X bar and Y bar, the means of X and Y. هذا أول شيء. ثاني شيء the width of this contour with respect to X will depend on what? Variance of X. While the width of this contour, depending on in the Y direction, will depend on the variance of Y. Now, if there is no correlation, if rho is zero, no correlation. Rho is zero, ايش معناها؟ Rho is the correlation coefficient, صح؟ C equal to هذه rho equal كم؟ CXY divided by ايش؟ Sigma X, sigma Y, صح؟ It's a correlation coefficient. احنا قلنا correlation coefficient. If it's zero, it means that they are uncorrelated, right? If rho is zero, it means that what? This will look like. This is X bar, this is Y bar. It will look like a circle. If the variance is this, obviously. If it is not zero, this is rho not equal to zero. And you will see it tilted towards right, left, whatever. So if you see a tilted locus, it means that they are correlated بينهم علاقة. زي ما قلنا الترند لو تتذكر لما رسمنا scatter plots, we said that if you have certain direction, certain trend, then you end up with correlation, صح؟ بينما if you have كل شيء مركز حول a circle, then basically you have uncorrelated. ولا كلام عن نفس الشيء هنا. If you have a locus that looks like there is a trend في the positive or the negative, it's basically بيضاوي لكن مايل. Then in this case you have rho not equal to zero. بينما if you have دائري أو بيضاوي لكن بدون ميلان. Then in this case you have rho equals zero. ايش معنى البيضاوي بس بدون ميلان؟ What does this mean? Variance Y exactly larger than X. Variance of X. صح؟ بينما هنا variance of Y ايش؟ Variance of X. Variance of X equal to Y. Now, what will be the shape if you have variance of X larger than variance of Y? Horizontal. حيكون بيضاوي لكن horizontal. ممتاز. Variance of X equal variance of Y larger than variance of X. Thank you. Right. And because when we put rho zero, X to Y independent. يكون راح نقول هي الآن correlated. نتكلم عنها. واضح شباب؟ So what we need to understand أول شيء الشكل العام، ثاني شيء the effect of the variance، الشكل العام of the PDF اللي هي البيل شيب، ثاني شيء we need to understand the contour of fixed values أو locus and the shape of these contours or locus, how they will look like if you have rho not equal to zero, rho equal to zero, and rho equal to zero with different variances. الآن your friend pointed out to a very important concept here. الآن احنا قلنا when rho equals zero means they are uncorrelated, صح؟ This is in the general any two random values with rho equals zero you have uncorrelated, صح؟ Now what about in jointly Gaussian? jointly Gaussian are those random values that satisfy this PDF. Joint PDF look at it. Now look at what happens if rho equals 0. What happens if rho equals 0? هذا هو صح؟ طب لما هذا يروح ايش يصير؟ You have only two exponents in the exponential. You have two exponents, and you can decouple them, like here. صح؟ And you end up with independent numbers. So two jointly Gaussian random variables that are uncorrelated are at the same time independent. بينما احنا قلنا قبل كده uncorrelated random variables احنا ما نعرف اصلا ايش شكل PDF. You cannot even talk about the independence in general random variables. However, for jointly Gaussian, uncorrelated means this is very strong. طبعا.
لو كان الهوريزونتال بيطلع يكون على بور زيرو.
اي لما يكون هوريزونتال لكن معناها ان البيس حق اكس لازم البيس هو يعني ما في واضح انه ما في علاقه بينهم. العلاقه متى تصير؟ لما يصير في ترند يا زايد يا ناقص، يا انه اكس تزيد وواي تزيد، يا انه اكس تزيد وواي تنقص. في ترند، عشان كذا تلاقي اللوكس يصير نايف اتجاه معين. However, horizontal or vertical means that they are not related. بس واحد منهم البيس حق يتغير اكثر. طيب شباب، clear؟ زي ما قلنا this is a very important and powerful concept that we use it a lot in chapter 6 when we talk about the random disease. So please make sure that you understand different concepts that we talk about. Then here we are plotting with different three-dimensional plot the different values, different cases. So here we have rho equal هنا 0.4 rho equal 0.4 هي ما هي واضحة. هنا rho equal 0.1 هنا rho equal 0.9. لو تلاحظ rho equal 0.9 there's a clear. لو تشوف كيف ال 3 dimension تشوفها كأنها بيل. however it's basically directed نحيفة جدا بالاتجاه هذا وتمشي كده. شايفينها؟ بينما هنا واضح انه تقريبا بالمتوازن تقريبا. هنا شوي البيل صاير في اتجاه اكثر، يعني صار في دايركشن اكثر في اتجاه الدياجونال. هنا لا، هنا ما له علاقه بالدياجونال، تقريبا بين اكس وواي متساوي ما في فرق. بينما هنا في دايركشن اكثر، هنا واضح انه في دايركشن. اوكي؟ Now here we are plotting in 3-dimensional PDF with the نسميها heat map. هذه heat map عبارة عن when you have a small value of the PDF you have very dark blue. As the value becomes larger and larger, you start to use the spectrum of colors until you reach the dark red. So basically dark blue, dark violet is basically the least value. In dark red means in dark value. So they use basically the spectrum of colors to represent different values. So basically this shows you how the locus look like. So basically if here we have 0.5. So this is basically rho equal 0.5. And this is rho equal to 0. And this is rho equal minus 0.75. So when you see rho equals 0, you can see that pure circle. فهنا two variances are pure circle. ما في أي اتجاه معين يخلي x يمشي مع y. Basically they are uncorrelated. بينما 0.5 تشوفهم as x increases, y increases. هنا you have 0.75 minus 0.75 as x increases, y decreases, and not only that لو تلاحظ هنا أعرض من هنا. هذا اللوكس صار أنحف بيضاوي أكثر because it's a larger negative correlation. Okay. كل ما يزيد أكثر يصير أنحف وأنحف. يعني مثلا if you plot rho equal 0.9 you will see that it will look like ايش رايكم كيف شكل 0.9 يعني حتكون عريضه جدا مثلا شيء زي كذا. اوكي عريضه جدا باتجاه معين لكن نحيفه جدا من ناحيه. واضح شباب الايفكت اوف raw and the variances. طيب now طبعا we can extend to any random values. كتبنا هنا this is optional, this is the optional. اللي جاي هذا included. So this is included. The optional only the first part, which is the n dimension. هذا included. Then we will use it. All this is included. Okay? So when you have n dimension هذا شكل يعني حيكون في حاجة اسمها correlation matrix, covariance matrix, sorry. هذه ال vector representation. We'll not talk about it. اللي مهتم يقرأ فيها. Okay? However, this is included from here. Okay? From the two, for two variables, we can write حاجة اسمها covariance matrix. ايش الكوفيرنس ماتريكس؟ الكوفيرنس ماتريكس C XY equals what؟ من اسمها ماتريكس. It's basically CXX, okay? CXY, CYX, and CY. Right. What is CXX? What is the covariance of X with itself? Well, these are definitions here. هنا يبين الفاهم واللي مش فاهم. What is the covariance of X with itself? CXX, what is it? Covariance of X, huh? It's basically expected value of X minus X bar multiplied by X minus X bar, which is X minus X bar squared. So this is by definition equals to the variance of X squared. What about CYY? Variance of Y squared. What is CXY? It's a covariance, CXY. Like we can write it in terms of the correlation as ايش علاقة CXY بالcorrelation؟ It's law. نتذكر الضوء عبارة عن ايش؟ CXY divided by sigma X sigma Y, صح؟ So we can write this as sigma rho sigma X sigma Y. And what about CYX? What is CYX? It's the same. So the covariance when XY here is the covariance when YX. So basically it's rho sigma X sigma Y. بعد هذه شوية. sigma Y. واضح؟ هذه نسميها covariance matrix. It's only a simple way to put things together. هذه نفس اللي كتبناها هنا. الآن if we write the covariance matrix like this, if we write the covariance matrix like this, then we can write بدل a two-dimensional PDF that looks like this, we can write it in terms of vector representation and matrix linear algebra. It will look like this. Where هذا عبارة عن ال X vector, هذا ال X bar vector. هذا ال covariance matrix. Covariance matrix inverse looks like this. ما كنا ناخذ تسوينها. طيب ليش عرفنا ليش why did we spend time for the covariance matrix? Because we will use it later when we do transformation for two Gaussian matrices. So just consider this as very important. نعم طبعا. وين هنا؟ لا أنا I use different positions. So. طيب الآن نحن تونا تكلمنا عن الفكرة اللي زميلكم جابها. When you have rho equals 0, you end up with joint PDF decouples into the individual marginal figures. So jointly Gaussian that are uncorrelated are زي ما قلنا this happens only in jointly Gaussian or jointly Gaussian random values. This is very powerful. زي ما قلت احنا دائما الكورليشن ما نعرف اي شيء عن البي دي اف، بينما في الجوينت جانكشن we know everything. Basically, if you want to know the PDF of X, of n random variables joint junction, you only need to have a mean vector and the covariance. What you only need. باقي ما تحتاج، ما في شيء اصلا تحتاجه غيره. طيب الان let's see if I have correlated Gaussian random variables. Correlated معناها بينهم علاقة with certain law. There is a correlation. Not zero correlation value between or correlation coefficient. I want to generate uncorrelated Gaussian random variables. باختصار أنا I have correlated random variables. I would like to generate uncorrelated. أبغى أسوي uncorrelation. Okay. Okay. Now, in order to convert that, وهنا ايش عندنا؟ X, Y are the correlated random values. These are the random values that have relationship. نبغى نسوي بينهم العلاقة. نبغى نحررهم العلاقة. So we define new random values Y1 and Y2. Y1 is X cosine theta and Y plus Y cosine Y sine theta. So what does this look like? Look like allocation of يعني Y1 will be allocation of X and Y. And Y2 will be minus sine theta and plus Y cosine theta. And we would like to find the covariance between Y1 and Y2. And the covariance between Y1. What is our goal, Ishmael? Uncorrelated. معناها Y1 Y2 لازم يكونوا uncorrelated. ايش يعني هذا بالنسبة للcovariance؟ Yeah, so basically we need to find this covariance and then set it to equal to 0. If we set it to equal to 0, then we find theta that will make this covariance equal to 0. If the covariance حق y1 and y2 equal to 0 ايش معناها؟ معناها y1 and y2 are what? Uncorrelated. واضح؟ So let's find out the covariance. The covariance عبارة عن y1 minus y1 bar multiplied by y2 minus y2 bar. So what is y1 minus y1 bar is x minus x bar cosine theta. Right? Y1 minus y1 bar is x minus x bar cosine theta plus y minus y bar sine theta. واضح؟ نضربه في y2 minus y2 bar which will be y2 عبارة عن ايش؟ minus x sine theta. So it will be minus x x bar sine theta plus y minus y bar sine theta. Cosine theta. Now the rest is just arithmetic or just open up the parentheses and collect similar terms. So when you multiply x minus x bar with minus x bar, what do you get? Minus x bar squared. And we have expected value. What is this equal to? Minus variance. So the first thing is minus the variance x. Multiplied by what? Cosine. So there's a cosine here. واضح? Now multiplying y minus y bar with y minus y bar and take the expected value. What do you get? The variance of y. Multiplied again by sine and cosine. Now the rest is multiply x minus x bar with y minus y bar. What is x minus x bar, y minus y bar when you have a equation? Covariance of x and y. So covariance of x and y, and you have cosine and cosine. So you have cosine squared. And the last thing is y minus y bar minus multiplied by minus x minus y, which is again the covariance. However, you have minus, you have sine multiplied by sine squared. Okay? Now, sine cosine equals half sine 2 theta. And cosine squared minus sine squared equals cosine 2 theta. Well, so what do we have here? We have half sigma y minus sigma x. So we have variance y minus variance x sine 2 theta multiplied by the variance between x and y, which is rho sigma x sigma y. Cosine 2 theta. Now, what do we want this to be equal to? 0. So we need this to be equal to 0 and find what rho should be. So, sorry, what theta should be. So when لا تنسوا انه عندنا احنا x و y, so basically rho is given, sigma x is given, sigma y is given. All these are given. The only thing that is not given here that we want to find is theta, such that the new random values are uncorrelated. So when we set this to 0, we find theta will be half tan inverse of 2 rho sigma x sigma y divided by sigma x squared minus sigma x. So now, if we start, why do we do this? If we start with certain correlated random values, x bar and y bar. So this is the center, the correlation value. Okay? Certain rho. Now, we want to transform this into uncorrelated. Okay, with rho equals 0. Then what do? We multiply by cosine. So the x, we define new random values, y1 and y2, such that what do you want to, for this to be uncorrelated? كيف شكل البي presentation? Circles, huh? So basically, in order for this to be like this, what do you want to do? You want to rotate this by certain theta, صح? This is exactly what we did. When you multiply x, when you define new random variable y such that it's equal to x cosine plus y sine, simply you are rotating this PDF into certain theta such that it becomes from بيضاوي إلى طبعا حيكون horizontal vertical إذا variances are different. The variance يعني the variance at x is different than variance of y, this will continue to be يعني بيضاوي point أو بيضاوي horizontal. صح؟ However, if they are not equal, and they are equal, it will be circle. الفكرة كالتالي إنك أنت you need to rotate this such that it becomes ما هي tilted لا يمين ولا يسار. واضح شو الفكرة؟ This is exactly what we have done here. Okay? So by rotating through theta, let's no. It's certain. Not equal to 0. And they are equal to 0. So this is again x bar, y bar. Now what do you have? What are these? هذا ايش كان اسمه؟ هذا كان x وهذا كان y صح؟ هذا ايش اسمه الآن؟ y1 and exactly. Two new random values. And new random values are different than x and y. However, they are related. هذول uncorrelated هذول correlated. هذول بينهم علاقة، هنا علاقة مزيح. We remove the relationship by forcing rho to be equal to 0.
So, real life,
Again?
real life, not complete.
أنت عندك في real life in many cases you have نقول عندك جهات معلومات that are related. لكن أنت ما تبغى نقول لا هي الفكرة كالتالي أنت you would like to have your system receive independent information. مثلا في اثنين نقول you have a system that you would like to play. using the average. الآن السيستم هذا when it perceives correlated images or correlated information, it will be biased. Why it's biased? Because it's perceiving something that أشياء يخلي لها علاقة ببعض. So basically, you are as if you are making the decision أو إنه تعلم شيء ما شيء جديد. You would like always to have what we call uncorrelated images. Uncorrelated images إيش معناها؟ أنا ما أعرف. But you train your network, you train your system into based على vectors or information that are not related to each other. This makes the learning process better and makes the results that will come better. فهذه موجودة في أماكن كثيرة يعني موضوع السيجناليزيشن.
أنت من الداتا نفسه مو فقط الاستقبال.
نعم الداتا نفسه.
الاستقبال كان المستقبل واضح
يعني خلينا نقول الآن نشوف الكورليشن يطلع من الداتا نفسه. لكن أنت الآن خلينا نقول إنك أنت يقول لك هذا أنت trying to find a good example, real example عشان نعمل أي discussion الآن. هي الفكرة كالتالي أنت الآن الداتا تيجي إكس واي هذه كلها من الريل لاين فهذه اصلا قابليه لكن انت الان you are trying to find مثلا ترين سيستم ترين نقول ام بي بوكس ممكن هذه اسهل شيء كنت تستفيد ولا الام بي بوكس انت الان عندك ايمجز تقطع من الشارع you would like to train certain network certain signals application network such that الاشياء اللي سويتها training it will be able to classify مثلا whether this is an image is a natural image or the image the image. Okay? Like all the images are reflected are coming from the same scene. كلها من جانب Okay? Around the same location. معناها ايش؟ في correlation عالية. In this case, your system will be trained at a very focused level. بينما مثلا ممكن you have another set of data that are يعني شويه related بدل كان بس مثل السنه يكون عندك شويه مختلف شويه لكن still بينهم correlation. انت الان you would like to remove this correlation and then do the thing. To remove this correlation you need to follow something like this. Why do you want to remove this correlation? To make the system more liberal. يحرر اكثر ما يكون مركز على مكان معين على داتا معينه على اتجاه معين. واضحه الفكره؟
بس احنا مثل الايمج اللي نعمل الفيديو والعلم ده من اوتسايد يعني اسم
بينهم علاقه
العلاقه اللي داخل الجامعه اللي برا مع اللي برا ما بينهم علاقه
ممكن يكون بينهم علاقه انه فيها شجر فيها اشياء فيها اشياء خلينا نقول ريبيت هنا وهناك. انت you'd like to make the system more liberal to see things that did not see before. عشان كده يجوا لي انفورميشن. ممكن يعني هي شوف اخر شيء الداتا عباره عن ايش؟ في فيكتور اكس فيكتور واي، الفيكتور هذا عباره عن collection of samples of random variable x. نتكلم عن الموضوع هذا random process. والفيكتور الثاني عباره عن collection of samples of random variable y. اخر شيء لما تقول random variable x انت ما عندك ما في شيء اسمه يعني at the end you are measuring صح؟ So you have certain samples x samples of y. Now هذا الsample of x represents random variable x, the sample of y represents random variable y. And you do all the لما تبغى تحسب المين حق الاكس ايش تسوي؟ تجمع كل السامبلز تقسمها على عددها صح؟ لما تبغى تحسب الكورليشن بين اكس وواي الكوفيرنس او الكورليشن تضرب كل فاليو اكس كل فاليو واي and you continue to do this and then you add and sum. صح؟ This is what you do. So basically at the end what you have when you say random value you have a collection of samples 10,000 1000 whatever هذه اكس وهذه واي. And in order to do this simply you need to define new random variables such that every value of x will be x, every value of the new random variable y will be the value of x cosine theta plus the value of y. You do it point by point and go multiplication. يطلع لك فيكتور جديد y1 وفيكتور جديد y2. هذا فيكتور جديد y1 are the samples of the new random variable y1 والفيكتور الجديد y2 will be the new sample of the samples of the new random variable y2. الآن y1 y2 because of this rotation. واضح الفكرة؟ شباب confused more ولا أوضح أكثر؟ So now some properties of the jointly Gaussian random variables. First of all, they are completely defined by first and the second moments. اللي نحتاجه بس المين والvariance and the covariance. لا تحتاج third moment ولا fourth moment ولا function. This is only what you need to know the full PDF of the jointly Gaussian. لو تذكروا ال PDF only depends on the mean of x, mean of y. So this is the mean of x and the mean of y. This is the mean of x, mean of y. This is the variance of x squared, variance of y squared, and this is the. If you know this, خلاص you know the whole thing. ثاني شيء uncorrelated random variables jointly Gaussian, they are independent. ثالث شيء, if I do any linear transformation of Gaussian random variables, I get also Gaussian. And we did not prove this. We will not do it here. However, this. Now تذكروا if I have two uniform xy, PDF of y, PDF of x. Nice, right? Uniform. When I add them, يكون independent. ايش يطلع PDF شكله؟ How to find the PDF of the addition of x and y? يعني convolution. The convolution ايش يصير؟ Triangle. So it will look like this. So it's not any more uniform. So this is f w, where w equals xn plus y. Now if they are uniform x and y, you end up with not uniform w. Remember, if you have two Gaussian random variables x and y and you add them, all linear transformation alpha ax plus by for a and b are constants, then you end up with also Gaussian random variables. Again, this is very powerful result. So simply, if your system inputs random Gaussian random variables and your system is linear, then the output of the system will be also Gaussian. So you don't need to find every time transformation. If you have jointly Gaussian, then the marginal also is Gaussian. Marginal. So if this is jointly Gaussian, then x and y are Gaussian random variables. إذا هم jointly Gaussian, then every one of them is Gaussian. Marginal is Gaussian. واخر شيء, but again we have to prove it, conditional density. So if I have x1, x2, and x3 are jointly Gaussian, then if I condition only one of them, then the other two will be also jointly Gaussian. So if three random variables are jointly Gaussian, then if I take the PDF of x1, x2 given x3, it will be also jointly Gaussian. Again, we will not prove this. Sure. Question? طيب هذا حليناه الآن. طيب سيبني أكمل شباب بس. طيب الآن we come to the last part of chapter 5. كثير الجاي شوية mathematically involved. Remember we did the transformation for single variable, right? For single random variable, نتذكروا نبدأ بداية السلايدز. كتبنا single random variable. When we have a single random variable transformation, we have the well-known result that we have done before. If you have monotonic transformation, so t x y equal t of x monotonic, then basically the PDF of y equals the PDF of x evaluated by x, which is the inverse of y, and the multiplied by the derivative of the inverse function. In the non-monotonic, you do the same thing, however, you repeat for all the zeros of this transformation. Zero means when you set tx equal 0, you find all the x's that basically make this 0. Now, this is if we have y a function of x, so y is a function of x. Now, what we do here, becoming in the rest of this class and becoming class, is when we have w equals a function of two randoms, x and y. Okay. So what we did in chapter 5 and chapter 3 was when we have single random variable transformation. Y equals t of x. Now, what about if we have w equals t of x and y? Okay. So in general, you can have multiple random variables applied to certain transformation G, and then you get the output. We will only focus on when we have only two random variables. Again, the same concept applies to all to when you have more than two. So here y is a function G. So this is the function G of x1, x2, okay. Now h times factor t, y was equal a function of x. فاحنا هنركز اكثر زي ما قلنا على two random variables. So in this case, if I, when we would like to find the PDF of y, we always start with the CDF, because the CDF is where the definition lies. So the CDF of y will be equal to the probability that y is less than a specific number. Now, what is y? Why is this? Why is this function? Now, in order to find the probability that something, a function of random variables, is less than a number, simply you need to integrate over this region. You integrate the joint PDF over this region. You want to find the probability that x is between A and B. What do? We integrate it to have A. From A to B, what? PDF of x, right? Now, if I'm looking at two random variables, probability of x between two numbers and y between two numbers. So if I want to find the probability that x is between A and B and y between C and D. So in this case, what do? Double integral between A and B, C and D of the what? Joint, exactly. Similarly, now we do the same thing. Now, however, we have, instead of having here a region in a line, a period in a line, or a square, or certain region in a plane, but here we have a region in a hyperplane. Right, زي ما قلنا هنركز على two values. However, this is the concept here. Now we'll find this, and then you do what? You differentiate with respect to one. هذه الطريقة ببساطة. هذا اللي سويناه قبل كذا، هذا اللي حنسويه الآن. However, only will focus on two random. Ready? Now let's focus only on two random variables. So when we have two random variables, and we have an example here. So this is a specific example of y equal g of x1, y1, which is x1 divided by y2, x1 divided by x2. Okay? And x1 and x2 are positive random values. ايش يعني positive? Means that they are not defined for negative numbers. Both of them are only defined for positive numbers. So x is not always larger than 0, and y is always larger than 0. So in order to find the PDF of a, y, we need first of all to find the CDF and then the definition. Now, to find the CDF of y, so we write the CDF of y, right? It's fy of y, which is equal to the probability. What was fy of y? It's the probability that y is less than a number, so. But what is y? We just write the function x1 divided by x2. Now, simply you need to find the region in the two-dimensional plane where this is satisfied and integrate the joint PDF on that region. ولا خدت الكلام هذا؟ أي كلام؟ Yeah, yeah. Which is the volume integral area integral. ما حندخل في التفاصيل لكن at least you need to know what. So now what do you do? When does x1 divided by x2 is less than 1? So simply you need to define a line where line هذا x1 equals y x2. This will be the line. So x1 is equal to y multiplied by x2. So this is the line. Now, what is our region here? So line H is equal x1 divided by x2 equals y. احنا نبغى ايش؟ larger ولا this line? This line. This line means ايش؟ Integrate to the right or to the left? To the left. So basically, this is our region of integration. Everything to the left of this line. And we only start from 0, 0 because they are positive random values. It's given. If it is not given in positive, معناها you draw a line all the way and you integrate from the whole region. لكن بما انه قال لنا positive خلاص we stop at 0. واضح شباب؟ So now what are the limits of integral? واحد منهم you take it from 0 to infinity, الثاني you take it from the line. Right? So basically here we are taking x1 between where and where? Between 0 and y x2. And y x2 will be from 0 to infinity. واضح؟ Now whatever the PDF, إلى ما تكلمنا إيش PDF. أي PDF, I can give you any PDF. It could be simple, it could be difficult. طبعا إذا simple حتكون أسهل، إذا صعب حتكون أسهل. الآن what do? We, in order to find the PDF, simply we differentiate this with respect to y. When we differentiate this with respect to y, أول integral ما له علاقة ب y, so it stays as it is. ثاني integral, limit is a function of y. So basically, ثاني integral disappears, and basically you need to differentiate with respect to y. So basically, if x1 equals this, then basically dx1 would be equal to x2 dy. So basically, you have x2 here because we differentiated this, and the same PDF continues. Whatever the PDF is, you need to work it out. واضح شباب؟ Next time we'll complicate it. Thank you very much.